Hi thinkers, welcome to the data structures in Python course on thinkexacademy.com. In this video, we're going to start with the merge sort algorithm in Python. So I'm going to divide this video in two parts. In the first part, we will understand the concept behind this merge sort algorithm. And in the second part, we will implement the same in Python programming. Now, in this tutorial, you will learn two very important concepts which we will use in competitive programming a lot, which is recursion and divide and conquer. So indeed, this is a very important algorithm to learn. So these are the two concepts, recursion and divide and conquer, which we are going to use. And these are actually we are going to use to be able to sort a given array. So let's try to understand why we need to learn merge sort and what are its advantages. So we can see the advantages of merge sort in time complexity. So here I'm just going to write time complexity of this particular algorithm. So these are the time complexity of this algorithm. The worst time complexity is big O of n log n, and the average and best are also n log n. So this is indeed a very good time complexity for doing the sorting algorithm, and even the worst case also. So now let's start with the algorithm and let's try to understand all the steps that we are going to perform. So basically we will do it in a lot of steps. So we will start with the first thing first, which is actually defining an array here. So the step one is to divide the problem into sub problems. So we are going to first use the strategy of dividing the problem. So I'm going to write here, divide the problem into sub problems. So the first thing you need to understand whenever you have any question, like even if you are doing competitive programming and you are given a problem, you can just consider it as a sorting problem or something like that. You just have to use the divide and conquer strategy. So the first step is to divide it into sub problems. But there are some constraints, some restrictions that you will have to follow when you are trying to divide a problem, right? You will understand it better when we are going to perform the sorting by using the strategy divide and conquer. So let's start with the very first step which is actually deciding how and from where we are going to divide this whole problem. So the problem is to sort this whole given array, and this array has n number of elements. So here n is 3, 4, 5, 6, 7. So there are 7 elements inside this array. Now we have to decide an element which we are going to use to divide this array. In merge sort, we use the middle position of the array. So here you can see that the middle position is actually 9. So what we will do is we divide the array into two sub arrays. So that is the first step, which is divide the problem into sub problem, or in our case we are going to divide the array into two sub arrays. And what are we going to use? We are going to use the middle position to perform the division. Okay, so now you can see here that I have divided the array into two sub arrays. Now the question is, how can we actually divide this array into two sub arrays? The answer to that will it lies in the concept of recursion, and we will come back to this question after this. We will do this dividing part. So we will understand how this dividing is done using recursion, but at this point we are actually understanding that division has been done using some strategy. So once the division is done, you need to conquer the problem, right? So that is the essential meaning of divide and conquer. So what is the problem? The problem is sorting problem. So here you can see that if I've divided it into these two sub arrays, I need to conquer the problem, which means I will have to sort these two sub arrays. Now the first thing here that you need to understand this is how to decide, how to check whether you can actually divide the problem into sub problems, right? The answer to that lies here. So initially the problem was to sort the array. After you divide the problem into sub problems, the initial problem should remain same, right? which you can see here that after division I've obtained these two arrays, and these two arrays are also unsorted arrays, so I also need to sort these two arrays, right? So the problem remains same. Now there is the second check, which is the second point. The second point is that if I am able to conquer these two sub problems, which means if somehow I come up with an algorithm which can actually sort these two sub arrays, so what I can do is I will have to check whether if I will be able to combine them, right? So if I combine these two sub arrays, whether I have an algorithm to combine them and get the sorted array, which is to solve the problem. So this is a very important thing. When you are dividing the problem, you will have to understand whether you are able to solve these two sub problems independently, and once you have solved them independently, do you have an algorithm or do you have a way to be able to merge them into a single array, and that single array should be sorted, right? So when you are merging the sub problems, they should solve the problem. So this is a very important concept. Now let's assume that we have come up with an algorithm. We will discuss the algorithm, how to merge these two, and we will also discuss how to sort these two arrays. And here we are assuming that I have come up with an algorithm which is able to solve these two sub arrays. So after sorting, this array will remain same, but this array will change. It will be somewhat like 1, then 9, then 12, and then 15, right? So if I have this solution, which is 5, 3, 10, 1, 9, 12, 15, I will use an algorithm to sort these two sub arrays, which is this one and this one, and we will discuss that whole algorithm here in this tutorial. But first we are assuming, it is an assumption that we have already done the sorting, right? So now these two are sorted. So now I will have to understand this is the first step, which is to understand whether I am able to write an algorithm such that if I merge this array, which is here, and this array, right, which are these are the two sub arrays. So if I can I merge them into a single array, and that single array should be solved or sorted, right? So let's move on to the next important step. Alright, so you can see here that after sorting the sub arrays, which we have assumed that we have come up with an algorithm, we will obtain these two sub arrays. So 5, 3, 10 will get sorted and become 3, 5, 10, and this will become 1, 9, 12, 15. So these are two sub arrays. So I'm going to mark this one as a left one. So this is L and this one is R. Now we are going to come to very important step, which is step 2, and step 2 says now we have to come up with an algorithm to be able to merge left and right, right? So this is very important step. I'm going to mark a star here. So we have to come up with an algorithm to merge these two sub arrays, right? And then we will come up to the part where we will understand how we can sort these two arrays, which these two sub arrays, right? So let's move on to the first point here. So we are going to pick three variables, I, j, and k, and initially all of these will have a value of 0. So let's understand what are the uses of these three variables. So the first variable is I, and I represents the index position of the left subarray. J represents the index positions of the right subarray, and K represents the index positions of the whole array, right? So now let's move on to the second point. So now what we are going to do is we are going to use a while loop, and we will keep incrementing the value of I, j, and k. But let's see, initially the value of I is equals to 0 and j equals to 0, right? So what we are going to do is we are going to compare these two positions. So I'm going to write here compare values at compare these two positions, okay? So now what we have to do is, in this point 2, we have two cases. We have case 1, which is let's say it is a case A. So I equals to 0, so I can actually get here L of 0, right, because I is the index position of the left sub array. And in this condition, what I'm going to say here is R of 0 is being compared to L of 0. So the first case is where this position L of 0 is actually less than R of 0. The second case, which is the B case, is the opposite of this case, where the position of L0 is greater than R0. So we are actually comparing these two positions, which is this one and this one. So in our case, you can see that 3, right? So first of all, we will also write what will happen if these two cases are met. So in the first case, when the value of the 0th position in L is less than the R, so I'm going to write here this important case, that if this happens, then according to the algorithm, we are going to just mark the array of 0th position will be equal to left of 0, and we will understand the concept behind this. We will understand why we are doing this, and then we will increment the value of I equals to I plus 1, and then we will also increment the value of k equals to k plus 1. Okay, so I will write for this case also. Here the case will be opposite. The array of 0th position will be assigned to the right of 0, and instead of I am going to increment the value of j equals to j plus 1 and k equals to k plus 1. Okay, so let's see how this step is actually merging L and R, right? So you can see what we are essentially doing is we are picking up elements from the left and right subarray one by one, and let's say we start from the 0th position. From both these positions are 0. So what we do is we compare them, and whenever we get a smaller one, we actually overwrite that element in the at the 0th position, right? So here you can see array of kth position, k is 0, so array of 0th position will become L of 0. And what we will do is, since we have actually appended this variable, now we will increment the value of j, or similarly we can increment the value of I also. So when we are picking the element from the left subarray, we are going to increment the value of I, because we want to move to the next element of this array, because this position has been already filled inside the array. So we will keep going, we will keep doing this again and again until and unless all the elements have been filled inside the array. So this is one important step. So let's take a look at the third iteration. So before moving to the third iteration, here you can see that in our case 3 is greater than 1, so this case will be applied, which is case number B. So when we will apply this case, what is the result that we are going to get? I'm going to write it here, that the resultant array is actually this. So this is the resultant array. You can see that we have overwritten the position 0 of 1, because 1 is lesser than 3. So 1 should come here ideally, and you can see the rest of the array is same as it was initially. So 3, 10, 9, 1, 12, 15 is the actual order, right? So now let's move on to the next iteration. Let's see what will be the status of the array when we will increment the value of, you can see that case is B. So the value of j will be incremented. So here the I will remain same, which is I will be equal to 0, and the j will actually increment to 1. So j will be equal to 1, and k will always increment because we are moving to the next position to overwrite in the array. So k will be equal to 1 also, right? Again, we are going to do the same thing. We are going to compare the position of L 0, and we are going to compare it with r of 1. So from here you can see that it is actually, we are comparing 3, which is at the first position, we are comparing it with 9, which is at the first position of this array, which you can see here. Now you can see that 3 is actually less than 9, so according to this we have condition A here, right? So what I am going to do here is, since this is case A, I will write that in this iteration case A will be applied, and according to case A we are going to overwrite the array of 1 will be equal to L of 0 will be equal to 3, right? So after we will do this, now let's see what will happen to our result. What is the result we are going to get? So the array will be equal to 1, and since this will change, this position will be 10. So here you can see that these first two positions look sorted, so I've marked them in the green color, and the rest of the array is actually not sorted, so it is in red color. Now what will happen is we will keep doing this. Let's move on to the fourth iteration, which is the last iteration that I will explain, and similarly the concept will go on, and that's how the whole array will get sorted. So now this is case 1, or the case A, where the I will get incremented. So now I will be equal to 1, and the value of j will remain same, so j will be equal to 1. K will change because every time we are actually trying to override the position. So here again we are going to compare L of 1 with R of 1. So what is the value of L of 1? Here you can see it is 5, and what is right of 1, which is 9. 5 is less than 9. Again the case A is applied here. So what we are going to do is let's see and let's take a look at the resultant array. So now you can see that the resultant array has 1, 3, 5, and this is sorted in green. 9, 1, 12, 15 is red, and it is not sorted. So this will keep going on like this, and the algorithm will work like this. So now we have an actual method to be able to merge two subarrays, which is the left and the right, and we can actually merge them into a single array, and we can get the resultant sorted array. So if I will keep overwriting these positions, I will get the required resultant array, which will have 1, 3, then 5, then 9, 10, 12, and 15. So this will be the contents of the array after this whole algorithm is solved. So this is actually the final result. Alright, so we will use this algorithm, we will write it in Python, but before moving on to writing the Python program, we will have to also do one very important thing, which is the concept which comes here, which is the concept of recursion. So basically we are going to use recursion to do this thing which is known as which we are actually doing to sort these two subarrays. So we are going to take a look at how we can actually sort these two subarrays. Alright, so let's see the role of recursion in dividing the array into two equal halves, and how we can keep going on dividing this array, and we can sort the array here, which is these two subarrays. So the strategy to solve the problem of sorting the subarrays can be done very easily by keep dividing the subarrays into more subarrays. So here you can see that 3 is the middle position, so I'm going to divide this subarray into two equal other halves. So the first array will have 5 and the second subarray will have 3 and 10. So the strategy is very simple. We will keep dividing until and unless we get a single element at the end, because at this point we cannot divide this array, and the problem that our subarray should be sorted is also solved here, because a single element is already sorted in nature, so we do not need to perform an algorithm to sort this. And similarly for this subarray, we will keep dividing it into two equal halves, which will be 3 and 10. And when we have these single elements, the problem that we want to sort the subarrays is actually solved here. So you can see that this is sorted and this is also sorted. We can do the same thing with the right part also, and we will make a recursive call to the merge sort function on two equal halves until and unless we reach a position where we have only single element inside of the subarray. And what we can do is, once we have done the division part and the first problem is solved, which is sorting the subarray, we can do and perform the merging part, which is to actually merge these two into a subarray. And we know that when we will merge these two subarrays, they are actually going to be sorted in nature. So if I will merge 3 and 10, they are going to come in the sorted order. Similarly, if you come here, 9, 1 will come here, and 12 and 15 will come here like this, and we will divide this again. So 9 will come here, then 1 will come here, and similarly 12 and 15 will come here. So these are now single elements which are sorted in nature. So now we know that once we have done the division part, we can now perform merging. So if I will merge these two again, now we know that the merging algorithm will first override the array here with the first position, and then 1 and 9 will come here like this. So this is how we can perform merging once we have single elements, and we will keep doing this again and again. You can see this 12 and 15 will get merged into a single subarray, and this is actually now a sorted subarray. And now again we can do the merging of these two subarrays into a single array by just using the algorithm that we have defined before. So 1 will come here, then we have 9, then we have 12, and then we have 15 here, right? So this is the result of you can see this is actually the result that we desire to perform the merging on these two arrays. So you can see that 9, 1, 12, 15 is now sorted, and similarly 5, 3, 10 will also get sorted, because if you merge these two, you will get 3 and 10, and if you merge these two, which is 5, 3 and 10, you will obtain 3, 5 and 10. And now you have these two subarrays, and you can now merge them into a single array, and that array will become a sorted array that we desired as part of the result. So it is a very simple thing that what we are just trying to achieve here is we are trying to divide it, and we are trying to merge them or conquer them, and we can now obtain the result. So the algorithm will be very simple. What we are going to do is we are going to create a function which will be the merge sort function, and this function will take the array ARR, and here when we are defining the merge sort function, what we are going to do is we will make a recursive call to the left and the right part. So I'm going to call the right and left part, but we will have to make sure that the recursion stops when there is only single element inside of the subarrays. So I will write a condition here that we are going to make the recursive calls only when the left position is, or we can say that the length of the array is less than 1, right? So if it is greater than 1, it means that there are more than 1 elements inside of the array. So then only we are going to divide the array. So once this condition is true, which is the length of the array is greater than 1, then what we can do is we can perform the division, and the way to do is to make a recursive call on the left and the right array, right? So how can I divide it into two? Let's say we have a array ARR. We can divide it into left and right part by using slicing of list. So array will initially be a list. Let's say this is a list, and we can divide it into two halves by using a slicing concept. So I will write a colon here, and I will write mid position. So what it does is it will divide this array into this first part, which will be from the starting till the mid position, and the second array can be obtained by doing the opposite. We will write mid here, and then we will write a colon. Now this colon is very important. If it is appended in the start, it means we are slicing from the starting, and if it is at the end, it means that we are slicing from the end. So here I will make a call to the merge sort function again, but on the left part. So left part is actually array of mid position from the start, right? So I can do this, and same thing I will have to do on the right part also. So I will have to make a call to the merge sort function on the right part, and the way to do is very simple. Just use mid and this. So this is indeed a good strategy, and there is one more strategy which you can do. We can actually allocate two subarrays, and we can use the left and right positions. Like I can actually specify left and right positions, and I can call the merge sort function on those two positions, right? And that's how we can actually divide a single array into two parts. But this is also a good strategy, and it also works. Now after we are done with dividing this, what will happen is, you can see this is a recursive call. These two are recursive calls here, which means that a function is calling itself. When such a thing happens, when recursion happens, what will happen is, let's say we have this merge sort function, and this merge sort function calls itself again. What will happen is, it is going to be stored inside the memory. So this function will have to, which is called after, this will have to first complete its execution, and after this has been executed, then only the first one will come into play. And let's say there are some more further calls to this merge sort function like this, and it will go until and unless there is only one single element inside of the subarrays. So what will happen is, once we are done with dividing part, now recursion by its nature, it uses a bottom up approach. So I'm going to write here bottom up approach, which means that the function which was called at the bottom will first complete its execution, and then the execution control will go to the previous ones like this, right? So when we are going to the previous ones, before that we want to actually perform merging. So at each and every step we are going to call the merge function, and at this position I will give it the array and the left and the right positions, and I will define the whole algorithm here to be able to merge these two subarrays, right? So we will keep merging, and we will keep going to the we are backtracking, or the bottom up approach is actually being used here. So after dividing, so this two are actually dividing the into subarrays, and this algorithm will actually use to do the merging part. You will understand this algorithm well when we will implement this in Python. So let's try to implement this same algorithm in Python also. Alright, so let's start by defining the array here, and the elements of the array in our example was 5, 3, then 10, 9, 1, 12 and 15. So this was our array. Now what I'm going to do is, I'm going to make a call to the merge sort function, and to this function I will just give the array, and after the call to the merge sort function, the array should be sorted, and I'm just going to print the array here. Now this is actually a list, so I'm going to write here that this is basically list in Python. Alright, so now let's do the important part, which is to define the merge sort function, and this function will take this array ARR. So the first condition that we need to write is that if the length of ARR is actually greater than 1, then only we are going to perform the division part. So at this position, now we want to actually create a mid position. So we want to analyze the mid position, and the mid position can be calculated very simply by using this formula, which is length of ARR modulus 2. So this is actually used to calculate the mid position. Alright, so now we have the left position and the right position, but we can get the left array, and we know that the left array we can get this from using this statement, which is ARR and mid then colon. So you can see that if I want to do the slicing from the starting, I write the colon from the start to the mid position, and similarly from mid position to the end of the array. Now what I will simply do is I will print left and print R to show you this whole thing in action, so that you can actually understand what exactly these two lines are doing. So I will simply write this, and let's run this program using Python 3, and the name of this is merge sort.py. So you can see here that this was our whole original array, which is 5, 3, 10, 9, 1, 12, 15, and it is now divided into left part, which contains 5, 3 and 10, and the right part contains 9, 1, 12, 15. So if I will make a recursive call to this merge sort function again, and I will pass this as the whole array, then this array will also get divided into two equal halves, which is the left and the right, which is 5, then 3, 10, right? So it will keep dividing. For that we will have to make two recursive calls here. So first of all, I'm going to edit here, and here I'm just going to make two recursive calls. First I'll write a comment here that this is a recursive call on the left and the right sub array. The way to do is this is very simple. Just write the merge sort function and call it on the left part, and same thing you will have to do with the right part also, right? So now we have these two functions, and we are done with dividing these two. So the program will keep dividing the array into two equal halves until and unless the length of the array is less than 1. So now let's move on to the very important part, which is to perform the merging of the two sub arrays, or I will write two unsorted sub arrays into single sorted array. Okay, so here we know that for that we will have to define three variables, which is I, then j, and then k. And now once we have defined them, we need to manage the cases here. So first of all, I'm going to just write here a while loop, right? So this while loop will actually start picking elements from I and j, and it will pick up until and unless the value of I is less than the length of the left. And similarly for j part also we are going to do the same. If the j is less than the length of right, we are going to run this while loop here, and I'm just going to first save this one, and I will just quit this terminal here. Now in this while loop, the first thing is we know that there are two cases. The first case is case A. As part of case A, we are going to use if statement, that if the left of ith position is less than equal to the right of jth position, right? So this was our case A. In that case, we are going to write array of k is equal to the left of ith position. We have already discussed it and we are just now implementing it. I will get incremented to 1. Now we need to manage the second case, which we will discuss in the else part, and here also we are going to do the same thing, but here instead of left I will write I here, and sorry, it will be j, right of j, and we will increment the value of j here. And now in this while loop I will write k equals to k plus 1. So after every iteration the value of k will get incremented. Make sure that the indentation is aligning with the while case and not with this else case. Alright, so this is the whole algorithm. We have done the merging, right? This is case A, and this one right here is actually case B. So we have managed these two cases. Now there is one more important case that I forgot to actually discuss, and now we are going to cover that. Now the thing here is, when we are moving from ith position in the left sub array and we are picking up the elements from right array and left array, it may happen that there are some remaining elements in one of these sub arrays. So it may happen that the left sub array is larger than the right, or let's say the left array is the left sub array has small number of elements, let's say 2 elements. So once the I iteration is done, right, once I has incremented and now it has reached its extreme position, in that case what will happen is there will be some elements in j which will remain, right? And this is happening because I and j are not necessarily equal in length, they might differ in length. So what will happen if there are some remaining elements in the left part, or what will happen if there are remaining elements in the right part? So we will actually we will have to manage that case. So if there are some elements remaining in the left part, we can just push them and override them in the original array. So let's manage this very important case. So I'm going to write here, for all the remaining elements in left slash right. So here what I'm going to do is I will write a while case that let's first check whether there are some remaining elements in the left or the right part. The way to do is very simple, just check the position I. So if I is less than the length of array, right, in this case I'm going to write here that this actually means that some elements left has some remaining elements, right? So if the left part has some remaining elements, let's see what we will do in that case. Here we are going to just do the same thing which we have done in the case A and B, which is assign the array of k equals to left of I, and we are going to increment the value of I equals to I plus 1, and I will also increment the value of k equals to k plus 1 because we now want to move on to the next position to overwrite in the array. So if there are any remaining elements in the left sub array, we will pick them one by one and we will assign them inside of the array, which is the original array, right? Now we will have to do the same thing with the right part also. We will again check whether there are some remaining elements in the left in the right part. So this is the way to do this, and again we will perform the same thing, which is instead of left I will write right of j, and now j will get incremented to j plus 1 and k will be incremented to k plus 1. Alright, so now we are done with all the cases here, and here I will write that this case actually says that right has some remaining elements, and now we are done with the merge sort algorithm. This function will overwrite all the positions inside of the array by dividing and by doing the comparisons, and then after merging we will get the sorted array. right? So let's run this program to see the output, and let's see whether there are some problems with this one, or is it fine. So I'm just going to clear this up, and here you can see it says list out of index. Okay, so it is causing at array k equals to left of I. So here you can see that I've written I is less than length of left. So this here is actually causing the problem. So alright, so you can see here we are writing length of array. It should not be the length of array, it should be the length of left, and here also it should be the length of right, because j will be less than length of right? So I will again save this, and let's run this program again really quick, and now you can see in the result that this array is now sorted 1 3 5 9 10 12 15. So this is how we are going to perform the merge sort function. So I will give this whole program with notes on our website thinkxacademy.com under the course data structures in Python. So make sure to like this video and subscribe our channel, and also share it with your friends to help this channel grow. So thanks for watching.